Lecture G2, Requirements for Comfort of the Building Physics section of this lecture series. It deals with the basics of required comforts, the PMV, the PPD, the air quality, and temperature profiles in rooms. And when we think about requirements for comfort, mainly heat is in our focus. Thermal comfort is the feeling of satisfaction within the ambient climate. But it's not only thermal comfort, we also have to deal with acoustic comfort and visual comfort as situations. Criteria for comfort: temperature, humidity, air velocity, so the movement of air, CO2 concentration, level of noise, and illumination as aspects. And when we deal with it, we have two main themes: the health of the user, the hygienic, which needs to be controlled, and the comfort of the residents or the user, which is the pleasant room climate. Influences, obviously, the outdoor climate, temperature, humidity, wind, rainfall, air pressure. Obviously, the behavior of the structure, so how does the building work, heat transport and heat storage behavior, but also moisture transport and moisture behavior within our building, and how well did we engineer it, so air exchange rates, which are defined, internal heat gains, we as person, and taking care of building service equipment, how this is used in the system. So the PMV index, the predicted mean votes, so what do people like most, what do people normally expect to be the most interesting part. It's a 7-point scale, too hot till too chilly, which we define, versus the PPD, the predicted percentage of dissatisfied people, in which we have a plus or minus, too hot, too chilly as well, and then a number of dissatisfied people. And you can imagine not everybody's going to be happy in a space when you engineer it. It's kind of impossible. So if you end up with a plus minus of 5%, so somewhere around here, 5% being dissatisfied, too hot, too chilly, we actually did good engineering. So it's impossible to get this down to zero. The required comforts, air quality. Here we talk about the CO2 concentration. It's 1,000 ppm parts per million, so per mil parts per million, which is named to be the level of acceptance. It's said that 1400 develops towards an unhealthy environment. Why is this important? Because our performance is decreasing, we lose concentration if CO2 concentration is too large in space. Temperature profiles are interesting as well. When I'm sitting here, I generate 120 watts. When I start doing slightly activity, it may be more. If I'm moderate or intensive physical active, it may end up with 270 watts energy by me into a room, and that's to be taken into account when you design the heating system for such rooms. The theoretical temperature, ideal temperature, which we see at the number 1, is cold at the top part and warm at the feet, so about 20 degrees, a bit less, and then cold at the feet, warm at the feet, and cold at our head. And when you look at number 2 and 3 radiators, or number 4 and 5 heating systems, we see obviously they heat up air, and this air raises in the room, and then the top part gets warm and the bottom part gets low, which is exactly the opposite as we wanted. So these heating systems may fulfill as an average for the room, but don't serve very well for us as a human being. Air heaters, ceiling heating devices, floor heating systems may be better as we see them here, but still they have a maybe average temperature in a room, which has a certain benefit, but it's not entirely what we need. Also, we need to identify that current or ongoing research comes to the conclusion that maybe variation in temperature during our day is also increasing our health in our indoor environment. We also can see that there's a close relation between relative air humidity and room air temperature. So if you see that room air temperature in this range from 18 to 22 degree being comfortable. We need to identify also that the 30 to 60% of humidity is something where we feel comfortable. If it's getting more humid, it doesn't feel comfortable. If it's getting colder, it doesn't feel comfortable. If it's getting too warm, it doesn't feel comfortable as well. So banal work or sitting work and maybe some physical exercise as different ranges. And obviously physical exercise is lower, so the comfort environment is lower because we distribute the energy by ourselves by being physical active. And then we come to this one, the final one in this small comfort lecture, which is the cold air drop. You're all aware of the heating system is here. It heats up the air gets into at the top of the room, and then this rotation of air happens, cold air coming down, being heated up again, and then the whole thing starts to move, which helps to get a kind of even equal distribution in this space. But if the window is too large, if the room is too high, there's maybe a cold air drop, which then makes it by the velocity within the room uncomfortable as a space. And by that, this lecture is finished. We talk about building physics, which we made a nice booklet about. There's the principles of facades, which may read. We have some lecture series in Darmstadt to be followed, and then obviously there's some regulations you may use for further investigation. And by this, I stop this lecture being part of the Delft Darmstadt Munich Facade Education project.